Welcome to the course Formal Language and Automata Theory. In this lecture, we will discuss the general concept of design of a PDA for a given context-free language. So here I have taken some example problems. By solving these problems, we will see how to construct a PDA for a given context-free language. So the question is, here you can see the question. Obtain a PDA to accept the language. Here the language is L equal to A power n, B power n, such that n greater than or equal to 1 by a final state. So this L is a context-free language. For this, we have to construct its equivalent acceptor, that is pushdown automaton. Whatever the PDA we are constructing here, so that is accepted by this language with the final state. So suppose in question, if they have given by empty stack or null stack, so at that time final state not required, the stack should be empty or null. At that time the PDA accepts the given language by empty stack or null stack. Now here whatever the stack, but it should reaches to a final state. So then we can say the PDA is accepted by a final state for the given context-free language. Okay, now come to the solution. So like any language will be given, language to language. So our logic is changed. So here we don't have a standard procedure or method for construction of PDA for a given context-free language. So here you can observe, first let us study the language, what it contains. So here the mission should accept, the mission means PDA, should accept n number of, here see what is the language A power n, B power n. So the language contains n number of A's followed by n number of B's followed by n number of B's. See, this order should be maintained. Here you can see the language contains A power n, B power n. First A followed by B. Then how many A's, how many B's? So here n should start with 1. Whenever you can substitute n as 1, what you will get A power 1, B power 1. That means AB is the string. If you can substitute n as 2, A power 2, B power 2. If you can expand this, A, B, B. So any string derived from this language, it should follows first number of A's, then number of B's. This order should be maintained. So that is the nature of the language. Then coming to the general procedure, what we follow here in this language. So here, since here we have n number of A's, the language contains n number of A's should be followed by n number of B's followed by n number of B's in the note whatever we mentioned. So this is the nature of the language. So here what you have to do in this, let us push all the symbols onto the stack. So the first step, what you have to do, push all the symbols, push means insert, all the symbols onto the stack, as long as the scanned input symbol is A. As long as the scanned input symbol is A. So why? Because the language contains number of A's followed by number of B's. First you have to push all the symbols on to the stack. as long as the scanned input symbol is A. That means whenever your input is A, you can push A onto the stack. Like that, all A's you can push onto the stack. So whenever the input is A. So then next second step, what you have to do? Second step, once we encounter the number of B's, once we encounter B's, then what you have to do? We should see that for each B, each input symbol B in the input, each B in the input, there should be corresponding A. There should be corresponding A. So this corresponding A, where this can be presented on the stack. Corresponding A should be on the stack. So then when the input pointer, reaches the end of the string. So whenever the input pointer reaches the end of the string, at that time the stack should be empty. The stack should be empty. So if stack is empty, it indicates that the string scanned from the input has n number of A's, followed by n number of B's, followed by n number of B's. That means here, if stack is empty, what it indicates? That the string scanned consisting of n number of A's followed by n number of B's. This is the general procedure. So here what you have to do, first you have to push all the symbols onto the stack as long as the scanned input symbol is A. So whenever input is A, you can simply push onto the stack. Like any number of A's you can push. So after pushing all input symbols, so whenever we will see the input is B, that means once we encounter B's, we should see that for each B in the input, for every B in the input string, there should be corresponding A on the stack. So when the input pointer reaches the end of the string, the stack should be empty. So whenever stack is empty, it indicates that the string scanned has n number of B's followed by n number of B's. So this is the general procedure we have to follow. Here, finally, the first step, we have to push all A's onto the stack. The second step, whenever we see the input as B, then there exists a corresponding A on top of the stack. At that time, we have to erase or pop the top symbol from the stack by seeing the current input symbol as B. So like that, whenever the control moves to the end, so all symbols on the stack should be erased. Then finally, stack is empty. So whenever stack is empty, it indicates so the string scanned from the given language. which consists of n number of A's followed by n number of B's. Now, by using the above two steps, now here you can write the corresponding transitions. Now, step 1, first, whenever we are designing a PDA or constructing a PDA, you can start with initial state. So let Q naught be the start state for any PDA. This is the common. Let Q naught be the start state, and also take the initial symbol of the stack. So Z naught be the initial symbol. Z naught be the initial symbol on the stack. So these two you can take initially for all problems. So then what you have to do, as long as the next input symbol to be scanned is A. In the above we mentioned, as long as the next input symbol, to be scanned is A, irrespective of what is there on the stack. What is there on the stack. So you don't bother about whatever the initial symbols on the stack. So as long as the next input symbol to be scanned is A, irrespective of what is there on the stack. So what you have to do? Keep pushing all the symbols onto the stack, and remain in same state. Here don't change state. So whenever you are pushing or inserting, and remain in Q naught, that is same state. Here we can't change the state. Now for this, the corresponding transitions. The transitions defined for this can be of the following form. So here we have taken Q naught as the starting state. So delta of Q naught. So your current input symbol is A. Initially, what stack contains the initial symbol, that is Z naught. So whenever your input is A, whatever stack contains, simply what you have to do, don't change the state, it remains in the same state. A is pushed onto the stack. Here you can see, initially this is the stack. Whenever input A is scanned, this A is pushed onto the stack. So here push A onto the stack. This is the first step. So then what we mentioned, like as long as any number of A's you can push initially. Now you are at same state. Now again second A we are pushing. Now what is the current top of the stack? Current top is A now. Now you can take A. So again whenever input is A, whatever the symbol on the stack, simply have to push A. Now A is pushed onto the stack. So here the stack becomes, already one A is there. Now one more A is pushed onto the stack. For this, this is the corresponding transition. So now by using these two transitions, here you can observe, first one A is pushed onto the stack. Then whenever your inputs is next A, again that A is also pushed onto the stack. So using these two transitions, you can push as many number of A's. So whenever your input string contains. So this operation we will call it as push operation in the first step. So here we have inserted A onto the stack. All number of A's are inserted. Then coming to step 2. In step 2, what we mentioned, whenever the input is B, the input B is encountered and there should be a corresponding A on top of the stack. So at that time, what you have to do, we have to pop the top of the stack with the opposite input symbol, that is B. With input B, we have to pop the top A. So that means here we have to erase all the symbols from the stack by seeing the input as B. So now we are at state Q0. So in state Q0, if the next input symbol to be scanned is B, if the next input symbol, if the next input symbol to be scanned is B, now our input is B now. Then whenever input is B, you can check the top should contains a corresponding A. And if the top of the stack, if the top of the stack is A, so what you have to do? In this case, simply change the state to new state. Let us say Q1. And what you have to do? You have to delete or pop 1A. So where A is there? 1A from the stack. So in the top of the stack, there should be corresponding A for the input B. So at that time, we have to delete or pop 1A from the stack. Now, the transition corresponding to this step is, therefore, the transition for this can be of the following form. So now you are at same Q0 state. Your input is B. Then there exists a corresponding A on top of the stack. Then we have to change the state Q0 to Q1. Now 1A from the top of the stack is erased or deleted. Means that can be done using epsilon. So here what you have done, pop A from the top of the stack. So this is the third transition we have. So now you are at Q1. So now again, if your next input is B, then there exists a corresponding A on top of the stack, that is second A. At that time also you can pop the second A from the top of the stack with the corresponding input B. So that can be done in step 3. That means we have more than one A on the stack. That's why there is chance of more than one B in the input string. So the remaining inputs also you can pop or delete by seeing the corresponding A's on the top of the stack. Now, once the mission in state Q1, now you are at Q1. Once the mission in state Q1, the rest of the symbols to be scanned, the rest of the symbols to be scanned will be only these. And for each B, there should be corresponding symbol A. There should be corresponding symbol A on the stack. corresponding symbol A on the stack. So like that you can pop or delete other A's on the stack by seeing the corresponding input symbol B. So then if there is a matching A on the stack, then the machine remains in the same state. Then it erases one A from the stack. Therefore, the transition corresponding to this one. Now you are at Q1 state. Your input is B. Your top of the stack is A again. Here we can't change the state. You will be at Q1 only. Now B A is popped by seeing the input symbol B again with epsilon. So here also again pop A. Here previously you can see you are at Q0, input is B, stack top is A. Then you change the state Q0 to Q1, then that A from the stack is erased with input as B. Now at Q1 state also one more B is there. Further all the scanned symbols are B, then there should be corresponding symbols A on the stack. Then matching is found. That means for every input B, there exists corresponding A. So whenever this will occur, then we have to pop up without changing the state. So like that, all A's from the stack are deleted or erased by seeing the corresponding input symbols, that is number of B's. So now coming to the last step. Now you are at state Q1. In state Q1, if the next input symbol is null or epsilon, that means now no inputs are there. So if the next input symbol to be scanned, next input symbol to be scanned is null. Here epsilon means null. And if the top of the stack is, and if the top of the stack is, now you erased all symbols from the stack. So then what stack contains? If all symbols are erased, then the stack contains the initial symbol only. That is what we assumed. Z0 is the initial symbol of the stack. And if the top of the stack is Z0, it means that for each B in the input, there exists corresponding A on the stack. So now change the state to Q2. Now what is Q2? Which is an accepting state. Which is an accepting or final state. So whenever input is empty, stack top is Z0, then you can change the state to new state, whatever the previous state, then it will move to next state. That you can consider it as the final state. Therefore, the transition corresponding to this can be defined as, now you are at Q1, input is empty, stack also contains initial symbol, then simply you have to change the state to Q2, then stack remains safe. So where Q2 belongs to final state or accepting state. So now you can see finally these are all the corresponding transitions of our PDA for the given context free language. So that is L equal to A power n B power n such that n greater than or equal to 1. So here based on this language, what it contains, number of A's followed by number of B's. So that's why the first step we have to push all A's onto the stack. Then whenever your input is B, then you have to pop or delete one A from the top of the stack by seeing the input as B. That means opposite symbols. So compulsory there exists a corresponding A whenever input is B. Then only you have to perform pop or delete or simply erase. So the first transition we are at Q naught state. Our input is A, initial stack contains Z naught. Then A is pushed onto the stack. Then the stack becomes A Z naught. The stack contains A Z naught. So whatever the element you are pushing, that will be placed on top of the stack. Every time the newly inserting element will be placed on top of the stack. Then second transition with the same state, if the input again the next input is also A, again you have to push that A onto the stack. Already your stack contains one A, then another A is inserted on top of the stack. Now this is the stack. Like without changing state, by using these transitions, you can push any number of A's. So now we are in the same state Q naught. If the next input symbol to be scanned is B, so whenever the input is B, then there exists a corresponding matching symbol A on top of the stack. Then only you have to perform delete or pop from the top of the stack. The corresponding A should be deleted. Then you have to change the state Q0 to Q1. Now the corresponding transition is delta of Q0, input is B, then top of the stack is A equal to, now we are changing state Q0 to Q1. Then erase means simply we have to put null. Here null means erase. Then here pop A. Then similarly now you are at Q1. Again if next scanned input symbol is B, then there exists a corresponding top of the stack is A. So then again you have to pop the next A also with the input symbol B. So then here without changing state, you are at Q1 state only, then pop A. Now you are in state Q1. So like that all A's from the stack are erased by seeing the corresponding B's in the input. So then in state Q1, if the next input symbol to be scanned is null, that means no input now. And in this case, the stack is also empty, contains Z0. Now we can change state to Q2. Now that state we'll call it as accepting or final state. For this, the corresponding transition is you are at Q1 state, input is empty, then stack also contains initial symbol. Then we are changing state Q1 to Q2. Now the stack remains empty. Now where Q2 is a final state or accepting state. Now these are all the transitions we obtain. Now finally write the final PDA by seeing all these transitions. So the PDA to accept the language. So what is the language? The language L equal to A power n, B power n, such that n greater than or equal to 1, along with the transition diagram is given below. Along with the transition diagram is given by, first we have to write the tuple definition of PDA, then list all the tuples. So here M equal to Q sigma tau delta Q naught Z naught and F. Now list out all the tuples here where Q equal to, what are the states we considered in the transitions? Here we have taken Q naught, then we have Q1, then Q2. Then sigma equal to the string consisting of A's and B's. So A comma B. Then tau equal to, that means after performing a transition, the right side of the move, what it contains. Right side you can see it contains Z naught, then it contains A. So stack contains Z naught and A only. So null we can't include as a stack alphabet. So now it contains A comma Z naught. Z naught is the initialer. start symbol of the stack, and delta is given below. List out all the above 5 transitions. Delta is given below. Now write down all the 5 transitions as it is. So now the first one is delta of Q naught A Z naught equal to Q naught A Z naught. Then the second transition, delta of Q naught A equal to Q naught A. Then the third transition, delta of Q naught B A equal to Q1 comma null. Then the fourth transition, delta of Q1 B comma A equal to Q1 comma null. Then the fifth transition, delta of Q1 comma epsilon comma Z naught equal to Q2 comma Z naught. These are all the transitions where here you can see Q naught belongs to Q is the start or initial state. Initial state of the mission PDA. Z naught belongs to tau is the initial symbol on the stack, and F equal to what is the final state here? Q2 is the final or accepting state. Like that, you have to write all these tuples, final or accepting state. So now draw its transition diagram for this PDA. So we know how to construct a transition diagram and table for a given PDA. So the PDA consisting of what are the states? Here we have Q0, then Q1, then Q2. So your initial state is Q0, so you have to draw a prefixed arrow. Then final state is Q2. You can represent within double circle. Now see the first transition Q0 on input A, it is going to Q0 itself. So Q0 on A, it is going to Q0 itself. Then the stack before after. So before the move, it contains A. After it contains A Z naught. That can be represented by separated with comma by using R. So A by A Z naught. Then second one, Q naught on A. Again, it is going to Q naught. Now the stack before the move is A. Then after move it contains A. Same. Next transition is Q naught on input B. It is going to Q1 state. So that third transition Q naught on B, it is going to Q1. Then what is the stack initially? It contains A. Then after the move, it contains null. So first input symbol followed by stack before after the move, separated with R. Both we have to include. Then next one is Q1 on B. Again loop. Q1 on B, it is going to Q1 itself. Now the stack before it contains A, then after operation it contains null. So now this one. Next transition Q1 with null, it is going to Q2. So here the input is null now. Initially stack contains Z naught, then after the operation also it contains Z naught only. So now that's all about the transitions. Now total see 5 transitions. So the here self loop we have 2 transitions, then Q0 to Q1 1, then Q1 loop 1, then Q1 to Q2 1 total. So 2, 3, 4, 5. All 5 transitions are included. Now this is the transition diagram of the PDA uptime. Transition diagram. Similarly, you can draw its table also. Transition diagram of the PDA uptime. Now here you can verify whether your PDA is correct or not. It's a very important step. You can take any one string, then you can check the acceptance. So here the mission, whatever the mission we obtained, it contains a final state. So compulsory, it is accepted by a final state. So let us take one string. To accept the string, the sequence of moves made by the PDA for the string, let us say AAA, BBB. If n equal to 3, you will get this string. So now the sequence of moves made by the PDA for this string are given below. First, you can take initial configuration, that is instantaneous description. You can take Q0 followed by the given string as it is, you can take, then take the initial symbol of the stack. Then one move to other move is separated by using this pipe symbol in ID. So now what you have to do, every time take the current state, current input symbol and current top of the stack. Then replace the respective transitions. Now Q0 A Z0, what we have according to first transition, the state is same. Now the remaining input after scanning A, remaining 2 A's, then 3 B's. Now this A is pushed onto the stack. Now A Z0. Now again your current state is Q0, current input is A, then current top is also A. Again Q0 AA. What is the transition we have? That A is also pushed onto the stack. So now another A is pushed onto the stack. Now the current top is A, current input is A. So again Q0 AA, same transition we can apply. Q0. Now the remaining input consisting of B's. Now this third A is also pushed onto the stack. Now you can see Q0 is the current state, current input is B, current top is A. So now according to the third transition, delta of Q0 BA. So it is changing state to Q1. The remaining input is BB. Now top of the A is erased or deleted with the current input is B. Now the remaining symbols on the stack. So AA Z0. Now your current state is Q1, current input is B. Then current top of the stack is A. Again Q1 BA. What is the transition? With same state, the remaining input is B. This A is erased. Then stack contains remaining symbols. Now your again current state is Q1, current input is B, current top is A. Again you have to delete A from the top of the stack. Now Q1, after scanning B, then remaining input is null. It does not contains any input. Then A is erased. Then your stack contains empty. Now the last transition Q1 epsilon Z naught equal to, it is going to final state. Now the stack remains same. Now here you can see this is called as final configuration. Final configuration. So what final configuration contains? So here, since Q2 is final state, here whatever the state we obtained here, Q2 belongs to F. Since Q2 is the final state, Q2 is the final state and input string is null. Input string is null in the final configuration. In the final configuration. So the string is accepted. The string AAA BBB is accepted by the PDA. Is accepted by the PDA. That means our mission satisfying the condition of acceptance of strings obtained from the given language by final state. So same problem by doing slight modification, we can obtain a PDA which can be accepted by empty stack or null stack also. For that, by changing the final transition. So now PDA accepted by empty stack or null stack. Empty or null stack. So only the last transition only you need to change. So by changing the final transition, by changing the final transition from the above PDA, from, so what is the final transition in the above PDA? So delta of Q1 epsilon Z naught equal to Q2 Z naught. So 2, this is changed to the following. So a PDA that is accepted by empty stack or null stack means stack should be null. Now Q1 epsilon Z naught equal to Q2 common null. This is the only change. So now which denotes empty stack or null stack. But here Q2 is not a final state. So now Q2 not belongs to a final state. So why? Because if the PDA wants to accept a given language by empty stack or null stack, only one condition means Q2 is not a final state. So the PDA accepted by an empty stack. The PDA accepted by an empty stack is obtained by changing the last transition to this one. So now here note that Q2 is not the final state. Now take the same string, whatever we verified the acceptance, you can test with this modified PDA. Now you can redraw its transition diagram also by changing only the last transition. Remaining all are same. There is no change. So like that, any given problem, a context-free language, we can obtain or construct its corresponding pushdown automaton by accepting with a final state or by accepting with empty stack or null stack. So if the problem is suppose construct a PDA accepted by empty stack or null stack, the last step we have to follow. Then construct a PDA which can be accepted by a final state. So at that time, the last transition you can keep remain same. So that means Q2 should be the final state. Then stack contains the initial symbol.